Imagine a world where physics seemed complete, where scientists thought they had all the answers. They believed the universe was a smooth, predictable machine. But what if, on a seemingly ordinary day in December, one groundbreaking idea shattered everything they knew? This wasn't just a discovery. It was the birth of a revolution that rewrote the very rules of reality. It happened on December 14th, 1900, in Berlin. On that day, one man introduced an idea so radical, it birthed quantum theory, a concept so strange, so profound, it underpins all modern technology and our deepest understanding of the cosmos. Before December 1900, physicists faced a baffling problem. They were trying to understand something called blackbody radiation. Imagine heating a piece of metal. It glows red, then orange, then white, emitting different colors or frequencies of light. Classical physics had formulas to predict this, but they catastrophically failed at higher frequencies, predicting an infinite amount of energy, an absurd impossibility. This was known as the Ultraviolet Catastrophe, a massive roadblock for physicists. At the turn of the 20th century, something fundamental about how energy worked was being missed. The universe wasn't behaving the way their elegant equations said it should. Enter Max Planck, a German theoretical physicist. He wasn't looking to revolutionize physics. He was trying to find a mathematical trick to make the black-body formulas work. And on December 14th, 1900, at a meeting of the German Physical Society, he presented his shocking, almost reluctant, solution. Planck proposed that energy, contrary to classical belief, wasn't continuous like a smooth ramp. Instead, energy could only be emitted or absorbed in discrete, tiny, indivisible packets. He called these bundles quanta. He introduced a fundamental number, now known as Planck's constant, to describe the size of these energy packets. This simple, yet radical, assumption instantly solved the ultraviolet catastrophe. His equations now perfectly matched the experimental data. At first, Planck himself thought this was just a mathematical trick, but his trick was the tiny seed that blossomed into quantum theory. Soon, brilliant minds like Albert Einstein, Niels Bohr, and Werner Heisenberg built upon Planck's foundation. Einstein used quanta to explain the photoelectric effect. Bohr used it to explain why atoms are stable. These ideas led to the incredible realization that particles can also behave like waves, and that observation itself can change reality. This strange, counterintuitive world of quantum mechanics, born from Planck's December revelation, isn't just theoretical. It underpins virtually all modern technology, from the lasers in our world to the transistors in your smartphones and computers, from medical MRI machines to the very LEDs lighting your screen. Quantum physics is at work. It's the engine of our digital age, allowing us to manipulate matter and energy at its most fundamental level. And the journey continues, with quantum computing and quantum entanglement promising even more mind-bending breakthroughs. So, as December arrives, take a moment to appreciate this month as the birthplace of the quantum revolution. A singular moment that unveiled the universe's secret and fundamentally changed our understanding of reality. If you're fascinated by the deep mysteries of science and the ideas that reshape our world, hit that subscribe button right now. Your next discovery awaits.